Hi, we're going to take a look at 11.5 with OR and problems and probability. So the big thing to start with is with OR probabilities, the probability of A or B means that the probability of A plus the probability of B minus the probability of A and B both. Okay, so this is our big takeaway here that we're going to be doing it. But why is this the case? So let's remember a deck of cards that has 52 cards in it. Let's find the probability that we have a heart or a 3. So the probability of a heart would be any of these here. Okay, so we can go ahead and circle. And then the probability of a 3 would be here. But notice when you do that, okay, so we can write that down. The probability of a heart plus the probability of a 3 minus the probability of a heart and 3. So the heart is 13 out of 52. The 3 is 4 out of 52. But then we counted this one twice, so we got to subtract off 1 out of 52. This one card that is a heart and a 3. So our result is 1650 seconds, which is approximately equal to 0.308. Okay, so this boxed in piece here, or problems will almost always contain the word or in the statement of the problem. For example, determine the probability of selecting a spade or a 7. Or or problems generally involve only one selection, such as picking one card or rolling one dice. So for the next page, we're going to think of it that we're going to pick one card. So we want to find the probability of a club or a jack. So the probability of a club would be 1350 seconds. The probability of a jack would be 450 seconds. And the probability of a club that's also a jack would be 150 second. So again, we end up with 1650 seconds like in the previous problem. All right, let's suppose a single dice is rolled one time. Let's find these probabilities. So a 2 or a 4. So we want to find the probability of a 2 plus the probability of a 4 minus the probability of a 2 and a 4. Okay, so we're just going to add those together, but notice it's 0 for the probability of a 2 and a 4. That's just not possible. Okay, when you roll a die, you have a 2, or you'd have a 4, you couldn't have a 2/4, or something like that. Okay, so when we combine those, that's just 1/3. Next is looking at the probability of an odd number or a number less than 4. So probability odd plus probability less than 4 minus probability odd and less than 4. Okay, so go ahead. Probability odd would be 1, 3, 5, so 3 out of 6. Probability of less than 4, 1, 2, and 3, so 3 out of 6, minus odd and less than 4, so 1 and 3, so 2 out of 6. Okay, so then we just end up with 6 out of 6 minus 2 out of 6, so 2/3 is our probability. All right, so pause for a moment, try numbers C and D. Okay, so for part C, probability of a number greater than 2 or less than 5. So p greater than 2 plus p less than 5 minus p greater than 2 and less than 5. So greater than 2, we have 4 situations there. So 3, 4, 5, 6. Plus less than 5. 1, 2, 3, 4. Again, 4 out of 6. And then minus greater than 2, but less than 5. So 3 and 4 gives us 2 out of 6. So we add those together and subtract, and we end up with 1, 100% probability that we would get a number that's either greater than 2 or less than 5. Notice on this number line, that's because it's overlapping. So greater than 2, less than 5, that covers the whole number line. For part D, we're looking for the probability of greater than 4 or less than 2. So greater than 4, less than 2, minus greater than 4 and less than 2. Was it possible to be greater than 4 and also less than 2? No. So what that means is we have 0 here for that possibility. So greater than 4, 2/6, plus less than 2, 1/6, we end up with 1/2 probability. Okay, next we're going to think about this TV show called The Voice. So I'll let you read the setup here. So notice there's 16 singers. Adam has 4, John has 4, Kelly has 4, Blake has 4. Now Blake has one of each type of singer, and the same for the rest of them. So we want to find a probability that a randomly selected singer sang pop music or country music. So we need the probability of pop music plus the probability of country music minus the probability of pop and country. Okay, so 4 out of 16 are pop. So we look up here, 4 of them are. 4 out of 16 are country, these 4. And none of them are both. So we get 1/2. Okay, let's think about sang pop or had Kelly as a coach. So probability of pop we already established was 4/16 before. Kelly has 4 people, so she's 4/16, but we need to subtract off someone who's pop and Kelly. So 1 out of 16 here, this person, we need to subtract off because we counted them twice. So really it's 7/16. Okay, had Blake or John as a coach. So probability of Blake, 4 out of 16. The probability of John is 4 out of 16. But Blake and John together, you couldn't have both of them as coach, so that's 0. So we get 1/2 as our probability. Sang rock and roll music or had Adam as a coach. So the probability of rock and roll is 4/16. Adam is 4/16. But then we subtract off the rock and roll and Adam. So that gives us 7/16. Okay, so notice sometimes we subtracted 0 when the events, and sometimes we didn't. So we subtracted 0 when these events are what they call mutually exclusive, such as 2 types of music or 2 coaches. So we want to determine whether these things are mutually exclusive. So the singer sings rock and roll and the singer has Kelly as a coach. Well, those are 2 different categories. It's possible to have both. So no, it's not mutually exclusive. Randomly selecting a singer on The Voice. The singer has John as coach or Kelly as a coach. Now that is mutually exclusive. You have one or the other, not both. How about if we look at as randomly picking a card from a standard deck of 52? The card is red or the card is black. Those are mutually exclusive. They can't be red and black cards. Okay. Same looking at a deck of cards here. The card is red and a 7. Well, there is a 7 that's red. There's more than one. So no, those aren't mutually exclusive. Rolling a die, the 2 is rolled and an even. Well, 2 is even. So again, not mutually exclusive. And finally, a 3 is rolled and a number greater than 4. So 3 is not greater than 4. Those two are mutually exclusive categories. All right, next we have AND probabilities. So our AND probabilities for us in this book, we're going to multiply these together. If we have P of A and B, that's P of A times P of B. A and B means first A occurs, then B occurs in that order. So why do we multiply? Let's consider this experiment of flipping two coins, a nickel and a quarter. Suppose that we want to find the probability that we flip two heads. So probability of a nickel, head on a nickel, and a head on the quarter. We can do a tree diagram. So what could happen? We could get a head or a tail. And then again, we could get another head or another tail. So if we wanted to find the probability that we get two heads, it's these two here. So 1 out of 1, 2, 3, 4 possible outcomes. So 1/4, and that is equal to 1/2 times 1/2. Okay, we can look at with more than two options. In this case, we have some jelly beans with replacement. So we're putting them back in after we're done. We have blue, red, and yellow. So we could get a blue, a red, or a yellow. And then again, we could get another blue, red, or yellow. And we want to know the probability that we pick a red and a yellow. So those two happening is 1 out of 9 outcomes. So 1/9 is our probability, which is equivalent to 1/3, which would be the probability of red, times a third, which is the probability of yellow. All right, let's suppose we have a spinner here. Oh, so and problems. Read that box. Okay, so for number 6, we have this spinner here. Now we can't really see what color is what, but this is blue, this is red, this is green. Okay, so we want to find the probability that it goes blue then red. So 1/4 is blue, 1/4 is red, just multiply them together. Red on both spins, a quarter times a quarter, 1/16. Green then blue, well green is a half, then blue is a quarter, so 1/8 in total. Now for number 7, we're looking at cards. Suppose two cards are randomly picked from a standard deck without replacement. Find the probabilities that we get 2 3s. Now the first 3 we'd get 4 out of 52 is our odds, because there's 4 3s in a deck of 52. Well, if we don't replace it, now we have 51 cards, and only 3 of them are 3s. So we get 3 51sts, and then multiply those together. For the probability of a heart and a diamond, we have 13 50-seconds for a heart, and then we have one less card, so 51 is our new denominator, but we still have 13 diamonds, so we don't have to decrease that. So then just multiply across. P spade and spade, we have 13 50-seconds for the first spade, 12 51sts for the second spade. Notice it decreased by 1. Okay, so under what conditions do we change the denominator? We need to change the denominator when we are picking cards without replacements. Okay, we're going to skip number 9. It just get kind of tedious there. So that's it. Please reach out if you have any questions, if you're getting different answers. Okay, talk to you soon.